Hello, my name is Patrick Foos, and my partner for this case study project was Varsha Golayala for POMS 5010. For our case study, we focused on Zhou Bicycle Company, and we helped create an inventory plan for this company. So to start off, I'm going to give a little bit of background about the company. Zhou Bicycle Company is a wholesale distributor of bicycles and bicycle parts based in Seattle. It was formed in 1981 by Young-Ping Cho, a professor from University of Washington. The primary retail outlets of ZBC are all within 400 miles of the distribution center. uh Cho Bicycle Company has this one bike product in particular called Airwing, which is their primary source of revenue. And all models of Airwing come from one manufacturer in China, priced at $170. Shipment takes up to 4 weeks from the time an order is placed at a cost of $65. The price paid on each bicycle is 60% its suggested retail price, and inventory's carrying cost is 1% per month. So to address some of the problems that we'll be talking about in this case study, Cho Bicycle Company is losing sales and distributors due to inventory shortage. There is no efficient inventory system. There is no restocking model or safety stocks. The suppliers have no problem getting the product from another distributor if it is on time with good quality. And finally, Cho Bicycle Company is losing their clients due to their lack of back order strategy. This is affecting the revenue of the company. So here is a model that was created for the Airwing bicycle, which was their primary source of revenue, talked about in one of the previous slides. As you can see here, they have the demands of what the model was back in 2017 for each month, and then in 2018, and they had the forecasted demand for the year of 2019. 2017 saw a total of 343 bikes in demand for that whole year. 2018 saw 391 bikes in total of the Airwing model for its total demand. And then 2019 was forecasted to have 439 bikes in demand for that whole year. And then you'll see on the right here, there is all of those years are graphed in a line graph, with the gray line at the top being the forecasted demand for 2019. So the three discussion questions that we were required to address in this case study were to develop an inventory plan to help Cho Bicycle Company. We were supposed to discuss the ROPs and total cost. And finally, we were asked how to address the demand that is not level throughout the planning horizon. Here is some of the case study data that we pulled from the text. Cho Bicycle Company is required to formulate an inventory model. Shipment takes 4 weeks from the time an order is placed. The order cost is $65. The purchase price paid by Cho Bicycle Company is 60% that of the retail price. The retail price of Airwing is $170 per bicycle. The carrying cost is 1% per month, or 12% for the whole year. And finally, ZBC wants to maintain a service level of 95%. So the inventory model that we chose to use was the economic order quantity model, which is an optimal quantity of inventory a company should order each time to minimize the combined cost associated with ordering and holding said inventory. From there, we will be able to calculate the safety stock, which is the extra inventory kept on hand in case of shortage, as well as the reorder point, which is the inventory level at which action is taken to replenish the stock. And finally, we will be finding the total cost for ZBC, or Zhou Bicycle Company. Now, from here, I'm going to play the recording of my partner, Varsha Golyala.
Thank you, Patrick, for the introduction. Now let's see our inventory plan. The average demand per month is calculated by the total demand per year divided by 12, which is 37 bikes per month. The order cost given in the case is $65. The cost per bike is equals to the retail price for Airwing, which is $170, multiplied by 60%, which is purchase price paid by the company. The holding cost is equals to the cost per bike multiplied by the carrying cost per year, which is 12%, which comes up to $12.24 per year per bicycle. The lead time given in the case is 4 weeks, and the total demand per year given in the case is 439 units. So in order to establish our inventory plan, for the company, we use the economic order quantity model. The EOQ is equals to 2 into capital D, which is the total demand per year, multiplied by S, which is cost per setup, divided by H, which is unit holding cost per year. Therefore, EOQ is the square root of 2DS divided by H. Putting all the numbers from the case study, EOQ comes up to 68 units of bicycle, which means within each order, the company should order only 68 Airwings. Now let's calculate the ROP and total costs. Before calculating ROP, we find the safety stock. Safety stock, like mentioned previously, is the extra buffer stock to allow for any uneven demand. Therefore, to calculate safety stock, the equation is Z score into standard deviation of the demand. The safety stock comes up to 48 bicycles. Now, to calculate the reorder point, we need the demand per day plus safety stock. The demand per day is 36.58 plus 42.35, which comes up to 79 bicycles. Thus, the reorder point ROP is 79 bicycles. The total cost can be calculated, which comes up to 932.61. The total cost is the cost incurred for the company for maintaining the inventory. One key factor to address the demand is for the company to closely monitor the demand patterns, the customer preferences, and the market trends, and adjust the inventory levels accordingly. It is also important to pay attention to what time of the year brings in the most revenue. The company can adjust the safety stock levels to accommodate the demand variability. The company should also adopt flexible inventory management for the safety stock. For this to happen, the company should make sure that a computer-generated system to be put in place to calculate the economic order quantity, EOQ, the safety stock, and the reorder point. Pre and post implementation. So previously, the company did not have any back order policy. Now it has an inventory management system where we calculate the ROP and the safety stock. The company had inventory shortage resulting in losing clients previously. Now the company has inventory surplus resulting in gaining clients and trust. Previously, the company did not have any strategic plan, but now it has a strategic plan to face any uneven demand from the clients. Conclusion. So, from developing our inventory model, we use the economic order quantity model in order to predict how many models of a certain bicycle the company can order at a time. Therefore, we calculated that 68 Airwing bicycles should be ordered consistently to meet the typical demand throughout the year. This model can be used for various other bicycle designs and predict how many units of a particular design should be ordered each time to meet the average demand. Thank you.
So thank you for listening to our presentation.